Okay, so our next presentation will be presented by Yaël Nazé, and she's going to talk about women astronomers.
Yes, so let me share my screen. Okay.
Yes.
Let me see if I can get it to work. Okay, whoops. Do you see it?
Yes, we can see it.
Yes, perfect.
Okay, so let me first say one thing is that the slides would be in French, but the comments would be in English. So Camille said it was preferable, so I stick with that. If there is any problem, just tell me. So following on what you just heard, I would like to focus a little bit on astronomy and present to you examples of what has been done in astronomy. The thing is, if you go anywhere and you just ask people to name an astronomer, well, basically you will get people like Ptolemy, Galileo, Halley, Herschel, Hubble, and you can recognize that they share a common characteristic, right? And you don't very often get a woman name in astronomy. But if you look at what they have done in astronomy, we do have quite a lot of very important discoveries that have been made by them. So if you look, for example, as persons who have really discovered a huge number of asteroids and comets. If you look at the organization of the stellar physics, how do we understand the stellar population? Well, it's also done by women. Or we can get distances. There is a very important law that was discovered by a woman. How do we have chemical elements in the universe? Because at first it was only hydrogen. So if you don't want to stick to hydrogen and go beyond, you need to find a way to build those elements. And it was a woman who come with this with a brilliant idea. And then even more recently, we have the discovery of pulsars and the discovery of dark matter, or the dark matter problem in galaxies. All those things were done by women. They are very important subject in astronomy, and still, well, if you ask people, we will give you a name of a male astronomer. So in fact, astronomy is a very long study, a very long history of having women in astronomy. In fact, the oldest thing we have comes from the girl of an Assyrian emperor, and she was called Enheduanna. And in Baghdad, she was the head of a temple dedicated to the moon. And in fact, it was an observatory, not only a temple for religious matter, but also an observatory. So it was more than 4,000 years ago, and we even have an image of her. Well, of course, it's not that good, but still, we have one. And in antiquity, we have a few other examples. So we have an Egyptian princess, and then a Greek woman who finally, in the 5th century BC, in fact, could be able to say when there was a lunar eclipse. And so she was, in fact, judged for sorcery, because people think like, okay, that is not possible to predict when eclipse arrive, and so she must be a witch of some sort. That didn't really improve with the next one, which is Hypatia of Alexandria. So she was a girl, the daughter of Theon of Alexandria. Theon was, in fact, the head of the very famous library of Alexandria, and he had only one girl. And he decided that it didn't make any difference, and so he explained everything to her. He even sent her to Athens to get a very good education. And so she was a very learned woman. She really had a lot of information to share. She finally became a teacher, but there were quite a lot of political problem, I would say, in Alexandria at the time, between the head of the city and the Christian, who were a small group at the time, but very vocal. And in the end, Christian monks just killed Hypatia of Alexandria, and the head of the monks was in fact sanctified for having killed her. So you see, it was not always a very easy thing, well, to be a woman astronomer at that time. Then, of course, if you look with age, there's a common thing that, you know, happens with time was mostly that you could get from time to time women astronomers if they had the chance to get education in astronomy. So the main problem was really getting access to the education. And so at some point, you finally had what I would call the domestic helpers. It is a class of women that were, I would say, hired in a sense by their fathers, their brothers, their husband, just because they needed help. And so in fact, usually what happened is that they had an assistant, a male assistant, and the assistant was really bad. And so they just put the assistant out of the house, and well, they didn't know what to do to get a good assistant. And finally they turned to the kitchen, they looked there, they saw that maybe that thing in the kitchen could think if you train it. And so finally they trained that person, and finally they became astronomer. And so we have a few famous example, in fact, just after Middle Age, mostly here from the German Empire. So you have König, Hevelius, and Maria Kirch. So the one you see on the right actually is Hevelius. She was the second wife of the astronomer Hevelius, and she survived him, and she actually was the one who made Hevelius' catalog. Since she arrived when he was a little bit old, as you can see here, she was making the observations. Maria Kirch is also very important. She is the first one who discovered the comet, who is recorded to have discovered the comet. In fact, it is published on the name of her husband, but everybody knows that it was her who did the discovery. And she, in fact, got the possibility to become astronomer of the Tsar in Russia. And she declined the position, and she even forbid her daughter to go there and be astronomer. In fact, she decided to stay in Berlin after the death of her husband, so that her and her daughter could help her son. So she continued to be an helper, and while she could have become independent in a way. Well, this line of action, I would say, has been quite long, in fact. So for example, you have some with very famous names. So you have Brahe, you maybe know Tycho Brahe, who was a very famous astronomer in the 16th century. In fact, he had a sister, Sophie Brahe, and Sophie Brahe, she married young. She was a widow very young too. And she, in fact, decided, because she had nothing to do, you know, she had money and no husband, so no child, nothing to do. She decided to do science. So she learned the pharmacology, she learned gardening, she learned a little bit of alchemy, and then she decided to learn astronomy. And at the end, Tycho Brahe, he was okay with pharmacology and alchemy and everything, but not astronomy. But in the end, she was really discussing astronomy just like a colleague. And so he said, okay, come to my observatory in Denmark. And so she went there and she did a lot of work with him. We know everything she did because there is a manuscript by Tycho Brahe that was unfortunately never published, but where he explained in the introduction that everything that was done after in the book, I would say, is done by, in fact, by his sister. Another one with a famous name is Caroline Herschel. So William Herschel was the discoverer of the planet Uranus. And in fact, he did a very big catalog of nebula. And for that, in fact, he couldn't do it alone. He needed someone to help him, someone to write the observations while he was looking through the telescope. And in fact, it was his sister that did that. And in fact, also when he was sleeping, she was organizing the catalog. So she actually made the catalog by herself, calculating everything, putting the positions and so on. And on the side, she was also observing by herself, and she discovered 8 comets. She was very famous at the time. I mean, not only because she was the sister of William Herschel, but because of her discovery and what she did in science, she was very, very famous. And when she went back to Hanover at the end of her life, every knowledge person who was going through Germany just, you know, make a small turn and go to Hanover to see her because she was so famous. I would say the last one in this line of helpers is Caroline Schumacher. Caroline Schumacher is not an astronomer by study. She did political science, so nothing really related to astronomy. But after, well, she married Eugène Astronomer, who was planetologist. And the problem was that after the kids had grown up and she was alone at home, she asked her husband to do something. And he needed help for his program related to near-Earth objects that could impact the Earth. And so finally, she went working with him, and she discovered 900 asteroids and 32 comets, one of which was a famous Schumacher-Levy 9 comet that impacted Jupiter in '94. I would say she's really the last of that line of helpers, the last one of the famous one. She's not that known compared to Caroline Herschel. If people often believe, even in the professional world, that the Schumacher-Levy comet come from Eugène Schumacher and not Caroline Schumacher. If we come back to the line of timeline, so we had, beginning in the Middle Age, I would say, the helpers, and then during the Enlightenment, well, some of the women could just, the rich women, could get education by themselves. And in this case, they were becoming more independent, and it was easier for them to choose to do something. And one of them, Marie Somerville, so she's a Scottish woman, she decided she just loved mathematics, and she just went through the library and so on, and did a lot of things in the library of her father regarding astronomy and mathematics. So her parents were not so fond of that activity, and so they decided to marry her, hoping that it would stop. The thing is that she became a widow very young, and so in fact she could finally do what she wanted. She married, in fact, another guy, so a medicine doctor called Somerville, and the guy recognized that his wife was so brilliant that he decided to move. So he decided to forget about his career in medicine and move to London so that she could meet astronomers there. And she was, in fact, a translator of the Mécanique Céleste from Laplace, but not only a translator, because she also did another book in addition to the pure translation to explain with exercise and so on. And it became a book which was very central to the education in the Anglo-Saxon world. So again, with Caroline Herschel, Marie Somerville is really, really very important in that. And they were really, really known very broadly. So when you arrive at the 19th century, in astronomy at least, people know that there were women can do astronomy. It goes to the limit that, in fact, the first universities in US, so women college in particular, well, in the curriculum, you had astronomy studies, in fact, which is a little bit weird, because if you look at the other things in the curricula, it's not at all linked to science. And the only scientific thing was astronomy, because of all those women astronomers, they thought that, okay, women can do astronomy, and so we can encourage that. So it is typical from US. You don't see that anywhere else, but they did have this astronomy session in those women college. So in the 19th century, they know that the woman can do astronomy, but of course they cannot do any astronomy. So basically people saying that at the time that, okay, they can do everything that require patience, and which is, well, in fact, let's say the word annoying. So everything that requires things that, you know, the male astronomer didn't like to do, well, that was for women. So of course, that implies that they could do the study, for example, of variable stars, of comets and asteroids. At that time, it was known that you could find them. patiently go through every day of the solar activity, or for example, you may know the name of structure on the moon. Well, that the naming of the structure on the moon was organized in the 19th century by a woman, because there were many naming schemes in parallel, and at some point some order had to be put, but it was really an annoying task, and it was a woman, Marie Blagg, who did that. And that is more or less when you will come to, I would say, a very big enterprise, which is in fact the computers. So the computers is a very important thing. It began, in fact, in the Enlightenment. The first one in those, if it works, okay. That was a French woman called Reine Lepaute, who did calculation by hand for the Paris Observatory. She was quite known, at least in France, and in fact, it was followed, but on the other side of the Atlantic, and especially in Harvard. In the Harvard Observatory, at the end of the 19th century, you had what was called the Pickering RM. So Pickering's RM, you can see Edward Pickering with some of the women of his RM. In fact, his problem was that he had a very small observatory at the time and not a lot of money. And he discovered that women were at least 3 times less expensive than men. So he could get a lot of employees for less money. So that's what he did, in fact, because he had a big project in mind, which was to look at the whole sky. And so, in fact, he decided to have the woman, and then he said to her, okay, here are the data, do something with them. And what they did is that they made what is called the Henry Draper catalog, which is a survey of the entire sky for the stars. And they organize it, not only measuring the position and brightness, but also organizing it in different spectral types, which is the basis of stellar astrophysics even now. And one of them, Henrietta Leavitt, discovered what is called the period-luminosity relation, which is very important for determining the distances, and which actually led to the recognition a few years later that the Milky Way is not the only galaxy in the universe, and that the sun is not at the center of the Milky Way. A little bit later, so after the Second World War, you got Margaret Burbage, who was interested with her husband into the composition of the universe. And so she was an observational astronomer, she associated with three theoreticians, so her husband, but also Fowler and Hoyle that you can see on the picture. And so they made in 56 a very seminal paper, which explains that the chemical elements are in fact synthesized in the heart of the stars, but also when they explode at the last phases of the stellar lives. And so this is a very important paper that was really making history, and is still correct for 95%, I would say, of its content. Then you got Vera Rubin. Vera Rubin is someone that asked more questions, which were not really welcome, I would say, in the community. So she had to change a lot of time subject because, well, what she was bringing as answers were not really appreciated. So first thing she asked was, okay, you have large scale movement, which are the expansion of the universe, but do you have anything else? And she shows that there were large scale motions in addition. It was not welcome at all. So she got to another question. You can see in books that the universe is homogeneous, but is it really true? It was not looked at the time. She did, and now it is, of course, something which is a very common area in astrophysics, but really at the time it was totally new when she discovered that it was not fully homogeneous. You could have parts which were more dense and parts which were really more void. It was at the time also that she became the first astronomer, first woman astronomer to be allowed to observe in the Paloma Observatory. And the reason why it was not before, it was officially because there were only one toilet. And of course, if there was only one toilet, it could only be for men. This is a small detail, but it shows you how you could put away women in some places. And so the last question she asked was about understanding the galactic rotation. And that's where she discovered that, in fact, contrary to the solar system, was the velocity in galaxies, it just level off. And for that, if our theory are true, you need more mass that you cannot see, so dark matter. And so she was a pioneer in dark matter. And this is the last question she asked, meaning that at that time, she had a lot of opposition, but she was just fed up by all those people saying that what she was doing was just bullshit, and she stayed in that area, and she became, of course, very famous for that. And the last one I would like to mention is Jocelyn Bell. She actually discovered the pulsars during her PhD. She had a very tough job, really, at the time. She discovered them. She discovered that it was a regular signal. Her boss was saying that, well, it must be extraterrestrial. She was not convinced. She thought it was natural. She stand to really in front of him, and finally she won, because of course it's totally natural. So the pulsars were found at the time and found, in fact, to be I would say dead stars that looks like lighthouse in a sense. But finally, the Nobel Prize, which was awarded for the discovery of those pulsars, was awarded to the boss, who had not asked her to look at that, who had not supported her, and who had said that it was extraterrestrials. And it was a really big scandal, and you had a lot of discussion, I would say. Even Margaret Burbage, for example, resigned from her post in UK because of that decision, for example. Okay, so I put here a few dates. I would just show you two. So one is 1893. That's the first PhD in astronomy given to a woman. It was in France, but it is an American woman, but it's in France. And the last one also. So the PhD was only open to women in Princeton University in 75, so nearly a century after. That gives you an idea how difficult things can be sometimes, and it's still very recent. So if you look at the statistics now, and I will finish with that, so the statistics of the astronomer on staff, right? You got an average of 21% women in the astronomical staff on average for the world. But it depends, of course, very much from country to country. So you have things which are better, like Argentina is 41%. France is not so bad, it's 26%. But then you have, of course, things where, well, countries where it's not so good, like Germany, which is 17%, Japan is 7%. I didn't even put those at 0%, which exists. But it's really like the previous person said, Mrs. Champenois, it's really the sisters that you can see here a lot, because if you look at the master studies in astronomy, the PhD students in astronomy, basically nearly everywhere you are at 50% women and 50% boys. And then if you look at the postdoc, you are already losing some part. You are at about 1/3, and it's decreasing, not increasing, because of postdoc stay are getting longer, and so it's more difficult. But still, if you go to the permanent position, it gets even lower than that. So the situation is not perfect still, despite the fact that you do have a lot of women astronomers in history, that things that have been done with the years to show those women a little bit more. So you have them on media, you have them in museums. So you have them a little bit everywhere, but still it remains a little bit low in the end. Not at first, not during the studies, but afterwards.